Welcome to the next podcast on quadratic equations. This one is called solving quadratic equations by the quadratic formula, the discriminant. In the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The part that's in the radical, that's this part right here, b squared minus 4ac, is called the discriminant. Now the reason that we call it the discriminant is because it lets us determine the character of the solutions without actually going through the whole process of solving the equation. And here's how it works, right over here. If b squared minus 4ac is 0, then this thing in the radical is a 0. So you only get one answer. The plus or minus doesn't mean anything because it's plus or minus 0, which doesn't change anything. So you only get one answer. It's a real answer. It's negative b over 2a. Now what happens if the thing in the radical is a positive number? Well, you can take square roots of positive numbers all day. Those are just real numbers. So we're going to get two real solutions, one corresponding to the plus and one corresponding to the minus. So if b squared minus 4ac is greater than 0, the radical is a real number, so we have two real solutions. What happens if b squared minus 4ac is negative? Well, then you're taking something like the square root of negative 4 or the square root of negative 30. The square root of a negative number we know is an imaginary number. Now you still get a plus answer, you still get a minus answer, so what happens is if b squared minus 4ac is less than 0, you get two imaginary solutions. Okay, let's see how this works in practice. Suppose I give you a problem that says, tell me the nature of the solutions for x squared minus 2x minus 3 equals 0. Now, before we perform this discriminant test, we've got to make sure we're in the right form for the quadratic formula. And the quadratic formula solved equations of the form ax squared plus bx plus c equals 0. Well, this is in that form. I'm in the right form. So I can easily determine my a, b, and c. A multiplies x squared, so a is 1. B multiplies x, so b is negative 2. C is the constant, so c is negative 3. And with that in mind, we can now calculate b squared minus 4ac. I'm going to do that since I've got some negatives here. I'm going to do that with empty holes. There's b squared minus 4ac. And now I just plug the appropriate numbers into the empty holes. b is negative 2, a is 1, c is negative 3. Well, negative 2 squared is 4. Negative 4 times negative 3 is positive 12. 4 plus 12 is 16. So I get that b squared minus 4ac is 16, which is greater than 0. And it says over here, if b squared minus 4ac is greater than 0, you get two real solutions. So what is the nature of the solutions? Well, there's two of them, and they are real numbers. Now let's make just a very, very slight modification to that problem. Instead of saying x squared minus 2x minus 3, let's use the discriminant to characterize the solution of x squared minus 2x plus 3. All I did was change the sign on the c. Again, it is in the correct form. So I can tell that a is 1, b is negative 2, just as before, and c this time is positive 3. And I go to compute the discriminant, b squared minus 4ac. Well, again, I'm going to use empty holes. There's b squared minus 4ac, and I'll just plug into the empty holes. b went in the first one, so I put in negative 2. A went in the second one, so I put in a 1. C went in the third one, so I put in a 3. Negative 2 squared, 4. Negative 4 times positive 1 times positive 3, negative 12, and I end up with the answer negative 8. Well, that's this case down here. If b squared minus 4ac is negative, then you're taking the square root of a negative. And if you take the square root of a negative, that's imaginary. So I get two imaginary, or you could call them complex, two imaginary solutions. One that corresponds to the plus and one that corresponds to the minus. Two imaginary solutions, and that completes our podcast on the discriminant.